A pleasant day everyone. I am Jasmine Navarro and for this video, I will going to discuss the theorems and properties of triangles. So let's define first what is triangle. So triangle is one of the basic shapes in geometry. Triangles are the polygons which has three sides, three angles, and three vertices. So based on the illustration, so we have here a triangle. So triangle has three vertices. So these are the vertices of a triangle or what we call the vertex. So it has three sides and it also has three angles of a triangle. So this is what we call a triangle. So let's start with the theorems and properties of triangle. First is the sum of the measures of the interior angle of a triangle is 180 degrees. So if we are going to get the sum or the sum total of the angles in a triangle, that is 180 degrees. So using the definition or theorems, let's solve for x. So for the first example, we know that this is a right triangle. So we have a perpendicular line here, so that measures 90 degrees. So we need to solve for x. So using the theorem, so angle A plus angle B plus angle C is equal to 180 degrees. So we have here x plus 90 degrees plus 45 degrees is equal to 180 degrees. Now, x plus 90 degrees plus 45 degrees, that is 135 degrees and equal to 180 degrees. And then x is equal to 180 degrees minus 135 degrees. So we apply the addition property of equality. So we subtract 135 on the left and then we subtract also 135 degrees on the right. So x is equal to 45 degrees. So therefore, 45 degrees plus 90 degrees plus 45 degrees is equal to 180 degrees. Next, for the second example, we have the given 110 degrees and 35 degrees, and then we will go to solve for x. So, x plus 110 degrees plus 35 degrees is equal to 180 degrees. Now, let's combine 110 degrees plus 35 degrees, and that is 145 degrees. So, we have x plus 145 degrees is equal to 180 degrees. Then, let's apply again the addition property of equality. So, we have x is equals to 180 degrees minus 145 degrees. So we subtract 145 on the left, then we subtract also the 145 degrees on the right side. Now we get 35 degrees. So we have 180 degrees minus 145 degrees, that is 35 degrees. So 35 degrees plus 110 degrees plus 35 degrees is equal to 180 degrees. Let's move on the third example. So we have this triangle and the given is 65 degrees, 70 degrees, and x. Now let's solve for x. We have x plus 70 degrees plus 65 degrees is equal to 180 degrees. So x plus 70 degrees plus 65, that is 135 degrees, and that is equal to 180 degrees. So we have x is equal to 180 degrees, so move the 135 degrees on the right side and then change the sign. So let's subtract it. 180 degrees minus 135 degrees, that is 45 degrees. So therefore we have x is equals to 45 degrees. Then 45 degrees plus 70 degrees plus 65 degrees is equal to 180 degrees. So that is the theorem about the sum of the measures of the interior angle of a triangle is 180 degrees. Now we have letter B. If two sides of a triangle are equal, the angles opposite these sides are equal conversely. So we have here a triangle. So if these sides are equal, therefore the base angles are also equal. So if this is x, the other base angle also measures x. So if this is 50 degrees, therefore it is also measure 50 degrees. Now, what if this is the missing, the vertex angle? So, using the definition or theorems earlier, which is the sum of the interior angles are 180 degrees, therefore this vertex or this angle measure 80 degrees. So 50 degrees plus 50 degrees plus 80 degrees is equal to 180 degrees. So this angle is the opposite of this side, while this angle is the opposite of this side. Next is letter C. An equilateral triangle has three congruent sides. So if we are going to draw or illustrate the equilateral triangle, it can be like this one. So all the sides have the same measure. So if this is 6 centimeter, therefore the remaining sides also measures 6 centimeter. So that is equilateral triangle. So equi means equal, then lateral means sides. So all the sides are equal. Letter D. The perpendicular bisectors of the sides and the bisectors of the angles of a triangle meet in points which are the centers of the circumscribed circle and the inscribed circle respectively. So the perpendicular bisector of a triangle is a line perpendicular to the side and passing through its midpoint. So we have here an illustration. So the three perpendicular bisectors of the sides of a triangle meet in a single point. Meet in a single point. So this is called the circumcenter. A point where three or more lines intersect is called a point of concurrency. So the circumcenter is the point of concurrency of perpendicular bisectors of a triangle. Here Here is O is the circumcenter of triangle X, Y, and Z. So the circumcenter is equidistant from the vertices of the triangle. That is XO is equal to YO is equal to ZO. So the circle drawn with the circumcenter, so this is the circle, as the center and the radius passes through all the vertices and is called circumcircle. So it passes in the three vertices of a triangle. So this is the smallest circle that a triangle can be inscribed in. So, therefore, when a circle circumscribes a triangle, the triangle is inside and the triangle touches the circle with each vertex. So that is a circumscribed circle. So we have another example, another illustration. So the angle bisector of a triangle is a straight line that divides the angle into two congruent angles. So this one. So it divides the triangle into two congruent congruent angles. So the three angle bisectors of the angles meet in a single point, and that is what we call the incenter. So this is the single point where the angle bisectors meet. So here is I is the incenter of triangle PQR. So the incenter is equidistant from the sides of the triangle. That is, PI is equal to QI is equal to RI. So the circle drawn with the incenter as the center and the radius equal to this distance touches all the three sides and is called incircle or the inscribed circle of the triangle. So this circle is the largest circle that will fit inside the triangle. So therefore, when a circle inscribe a triangle, so when a circle inscribe a triangle, the triangle is outside of the circle and the circle touches the sides of the triangle at one point on each side. So this is the circle. Letter E. The altitudes of a triangle meet in one point or the orthocenter. So the altitude of a triangle is a perpendicular line that is drawn from the vertex to the opposite side. So this vertex, and this is the opposite side, and this vertex and its opposite side, and this vertex and its opposite side. So since there are three sides in a triangle, three altitudes can be drawn on it. So observe this illustration of triangle. See the point where all the three altitudes of the triangle meet. So this point is known as the orthocenter. So this point is known as the orthocenter. So this is the point where the three altitudes of the triangle meet. Letter F. The medians of a triangle are concurrent at a point which is two-thirds of the distance from any vertex to the midpoint of the opposite sides. The point of concurrency is the centroid of the triangle. So, the centroid of a triangle is the point where the three medians coincide. So, the centroid theorem states that the centroid is two-thirds of the distance from each vertex to the midpoint of the opposite side. So, therefore, in this illustration, we have QV is equal to two-thirds of QU. And we have PV is equal to two-thirds of PT. And we have RV is equal to two-thirds of RS. So that is what the centroid theorem states. Then we have the exterior angle theorem. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles of the triangle. So let's say we have a triangle and also the exterior angle. And we have the two remote interior angle, which will be our given. So let's say this angle is 50 degrees and the other angle measures 65 degrees. So let's find out what will be the measure of the exterior angle. So let's say this is x, the exterior angle. So the measure of angle x is equal to the sum of the two remote interior angle, which is 50 degrees and 65 degrees. So we have 50 degrees plus 65 degrees, that is 115 degrees. So the measure of the exterior angle is 115 degrees. So if this is 115 degrees, uh, if this is 115 degrees, we can get the measure of this angle. So 180 degrees minus 115 degrees is equal to 65 degrees. So applying our first theorems, if we are going to add the interior angles, we get 180 degrees. So we have 65 degrees plus 65 degrees plus 50 degrees, that is 180 degrees. Letter H. Two triangles are congruent if two triangles and the included side of one are equal, respectively to three sides of others. So therefore, two triangles are congruent if two angles and the included side of one are equal respectively to other, and it is also congruent if two sides and the included side angle of one are equal respectively to two sides and included angle of the other. So we can say that this is the angle. So we have angle A and we have angle B. So this is the included side. And also we have angle E, or let's say we have angle B and we have also angle E. So this is the included side. So we can say that these two triangles are congruent. Now let us familiarize the side and angles of a triangle. So let's say we have triangle SEC. So we can say that angle S is opposite to side EC. Likewise, side CE is opposite to angle S. Next, angle E is opposite to side SC. Likewise, side CS is opposite to angle E. And then we have angle C. Angle C is opposite to side ES. Therefore, side SE is opposite to angle C. So that is the side and angles of triangle. So those are the theorems and properties of triangles. So that's all for this video. Thank you for listening.
So hello guys, we will talk about Pythagorean Theorem. First, we will define what theorem is. Theorems are what mathematics is all about. A theorem is a statement which has been proved true by a special kind of logical argument called a rigorous proof. Right triangle. A right triangle is a type of triangle that has one angle that measures 90 degrees. In a right triangle, the side that is opposite of the 90 degrees is the longest side of the triangle and it is called the hypotenuse, which is the side C here in given illustration. There are many theorems of a right triangle, but now we will talk about Pythagorean theorem, the well-known geometric theorem that the sum of the squares on the legs of a right triangle is equal to the square on the hypotenuse. A square plus B square is equal to C square. Here's a special example. This is a right triangle that the three sides are given. The measure of side A is equal to 3, side B is equal to 4, and side C is equal to 5. We will use the Pythagorean Theorem, which is a square plus b square is equal to c square, to know if these sides have a geometric relationship between these three sides. Here is the substitute the given. 3 square plus 4 square is equal to 5 square, since A is equal to 3, B is equal to 4, and 5 is equal to C. In order of operation, we need to solve first the exponent. 3 square is equal to 9, 4 square is equal to 16, and 5 square is equal to 25. 9 plus 16, 25 is equal to 25. Therefore, we can say that Pythagorean theorem shows a geometric relationship between the three sides of a right triangle. We have here in our board a right triangle, which is triangle ABC. Our hypotenuse can be labeled as C because this is C and the opposite is side C. Angle B, opposite is angle B, side B. Angle A, the opposite side is angle A. Our Pythagorean theorem is the sum of the squares of the two sides is equal to the square of the hypotenuse. A squared plus b squared is equal to c squared. If side B is the unknown side, we can use the formula b squared is equals to a squared minus c squared. And if the side A is unknown, we can use the formula a squared is equal to b squared minus c squared. Pythagorean theorem is used to find the unknown signs. It is the best used tool to find the unknown sides of a right. Theorem is also a best tool for us to know if the given triangle is really a right triangle. So, because we cannot say that the triangle given to us is already a right triangle if the three sides are given. So we can use the Pythagorean theorem to let us know if the triangle is a right triangle. I said earlier, Pythagorean theorem can be used for us to define or for us to know if the given triangle is a right triangle. We have here a triangle ABC, and we didn't know if it is a right triangle because the three sides only given. So we have here side A is equivalent to B, side B equivalent to 3 also, and our hypotenuse is equivalent to 4. So using the Pythagorean theorem, a square plus b square is equal to c square, we can know if this triangle is really a right triangle. Substituting the given, a is equal to 3, and our side b is equal to 3 also, and our hypotenuse is equal to 4. 3 squared is equal to 9, plus 3 squared is equal to 9 also, and our hypotenuse, which is 4 squared, is equal to 16. 9 plus 9 is equal to 18, and our square of our hypotenuse is 16. 18 is not equal to 16. Therefore, we can conclude that triangle ABC that has sides 3, 3 and has hypotenuse which is 4 is not a right triangle. So guys, I'm giving you an example for you to understand Pythagorean easily. So we have here the given right triangle ABC, and the two sides are given, which is side A is equal to 6, side B is equal to 2. We have to find the unknown sides, which is the hypotenuse. So for us to find its length or measure, we are using the Pythagorean Theorem. Pythagorean Theorem is a squared plus b squared is equal to c squared. So substitute the given a squared. A is equal to 6 plus b is equal to 2. C squared is equal to 36 plus 2 squared is equal to 4 and is equal to c squared. 36 plus 4 is equal to 40 c squared. So this c has square, so we have to inverse it, square root both sides, so that the square here will be cancelled out. Therefore c is equal to square root of 40. Square root of 40, we can factor this out, which is c is equal to 40, 4 times 10. So since 4 is a perfect square, we can say that c is equal to 2 square root of 10. And that is our measure of our hypotenuse.
So, a pleasant morning to everyone. So, our topic for today is about 45-45-90 right triangle theorem and 30-60-90 right triangle theorem. So, before we proceed to our topic, as we all know guys, we can solve for the side of a triangle or of a right triangle by using the Pythagorean Theorem. Pero, meron tayong special cases. Ito nga yung 45-45, 90 right triangle and 30-60, 90 degrees right triangle. So, kapag given ang angle ng triangle natin is 45-45, tapos yung right angle natin is 90 degrees, this is theorem, or we can use this theorem na di na tayo gumagamit ng Pythagorean theorem to solve for the legs or hypotenuse of the right triangle. So, right triangle whose angles measures 45-45, 90 degrees or the 30-60, 90 degrees are referred to as special right triangles. So, the Pythagorean theorem gives us information about the special right triangles. So, we prove that in a 45-45-90 right triangle or in an isosceles right triangle, the hypotenuse is square root of 2 times as long as each leg. So, ipoprove daw natin na yung hypotenuse is square root of 2 times the legs. So, prove given isosceles right triangle ABC with legs or length, okay, A and hypotenuse C. So, prove that C is square root of 2, okay, proof, okay, by using the Pythagorean theorem, okay, we have C squared is equal to A squared plus A squared is equal to 2A squared. So, as we go back, okay, kung babalikan natin yung nakaraang discussion na Pythagorean theorem, kung matatandaan natin na meron tayong formula dun na c squared sa Pythagorean theorem na c squared is equal to a squared plus b squared. So, since wala tayong b dito, kaya parehas na a yung ginamit natin. So, a squared plus a squared is equal to 2a. Alam naman natin na pag rational is bawal yung may radicals. So, kailangan natin tanggalin yung squared sa 2a. So, anong gagawin natin is lalagyan natin siya ng square root para ma-cancel yung squared sa a. So, magiging sagot is 2 square root of 2a. Okay? 2a. So, na-prove na natin na okay, applicable siya sa hypotenuse. So, ang formula na natin sa hypotenuse kapag given hypotenuse is equal to square root of 2 times the leg. So, okay, proceed na tayo sa next slide. So, next slide natin is 45-45-90 right triangle theorem. In in a 45-45-90 right triangle, each leg is square root of 2 over 2 times the hypotenuse. And the hypotenuse is square root of 2 times each leg. So, ito yung formula natin. So, formula natin kapag hinahanap natin ang leg, so, is equal to, leg is equal to square root of 2 over 2 times the hypotenuse kapag given yung hypotenuse. Then, h, okay, hypotenuse is equal to square root of 2 times the leg. Kapag hinahanap naman natin yung hypotenuse, square root of 2 lang, tapos times natin siya sa leg. So, ganun lang kadali guys. So, meron tayong example dito. Example number 1. As we can see the triangle, so 45, okay? Meron tayong given na 45 dito. So, ang given natin is if h is equal to 5, then what is the length? So, ano daw yung length natin? So, as we go back, okay, yung formula ng length natin kapag hinahanap is length is equal to square root of 2 over 2 times the hypotenuse. So, since yung hypotenuse natin is 5, so yung 5 times square root of 2 over 2 is equal to, length is equal to 5 square root of 2 over 2. So, ganun lang siya kadali guys. Then, next, if L is equal to 12, then what is our hypotenuse? So, yung hypotenuse natin naman yung hinahanap. So, kapag hypotenuse lang hinahanap is square root of 2 times the leg. Then, so, yung length natin is 12. So, i-multiply lang natin siya sa square root of 2. So, ang sagot is h is equal to 12 square root of 2. Ganun lang siya kadali guys. I-multiply lang natin siya. Hindi na natin kailangan na mag-calculator pa. So, yun lang guys. So, next na tayo sa next example. Then, so, proceed na tayo sa next example natin. So, a square shape handkerchief measures 16 inches on each side. You fold it along its diagonal. So, you can tie it around your neck. How long is this tie? So, yung tie naman kung gaano, illustrate natin siya. Kunyari, yung handkerchief natin ito, yung rectangle. So, nag-drawing na tayo ng diagonal. So, itutupi daw natin siya. So, magiging right triangle siya. So, yung hinahanap natin dito is yung hypotenuse. So, given na yung leg natin na, which is 16. So, ang formula ng hypotenuse natin is h is equal to square root of 2 times the length, which is 16. Square root of 2 times the length is equal to, h is equal to 16 square root of 2 inches. Pero kung decimal naman yung hinahanap is 22.63 inches. So, itatype lang natin siya sa calculator ng 16 square root of 2. Then, lalabas na yung inches. So, ganun lang siya kadali guys. Then, sa next naman, sa 30, 60, 90 degrees right triangle theorem. So, in a 30, 60, 90 triangle theorem, the hypotenuse is twice as long as the shorter leg. And the longer leg is square root of 3 times as long as the shorter leg. So, ito yung formula ng, meron tayong apat na formula dito sa 30, 60, 90 triangle. So, yung 30 natin dito, 30 degrees, ito yung pinakamakipot natin or shorter leg. So, yung 60 natin, which is the longer leg. So, tingnan natin yung symbol nila, yung hypotenuse, yun yung the hypotenuse is the twice as long as the shorter leg. So, yung hypotenuse natin, ito, meron tayong apat na formula dito. So, ang formula natin kapag hinahanap natin yung shorter leg, okay, kapag shorter leg yung hinahanap natin is 1/2 times hypotenuse. Kapag given yung hypotenuse natin. Pero kapag hindi given yung hypotenuse natin at given yung leg natin is, kapag hinahanap natin yung shorter leg is, shorter leg is S is equal to square root of 3 over 3 times the leg. Okay? Ganun lang siya kadali guys. Then, kapag leg naman yung hinahanap natin, okay, leg is equal to square root of 3 times the shorter leg, yung shorter leg natin, times natin siya. Then, kapag yung hypotenuse naman yung hinahanap natin is twice the shorter leg. Ita-times 2 lang natin siya, yung shorter leg. Okay? Then, proceed na tayo sa example natin, guys. So, meron tayong, as we can see, example natin dito is S is equal to 6. Okay? Then, what is the length and the hypotenuse? So, ang hanapin muna natin is length. So, ang given natin is shorter leg. So, kapag ang hinahanap natin is leg is square root of 3 times the shorter leg. So, yung shorter leg natin is 6. So, okay, leg is equal to square root of 3 times, okay, yung 6. So, 6 is square root of 3 yung sagot natin. So, kapag i-multiply natin siya, hindi na tayo gagamit ng calculator, guys. Ganun lang siya kadali. Then yung proceed na tayo sa hypotenuse. So, makikita nyo dito sa gilid, h is equal to 2 times the shorter leg. So, yung shorter leg natin is 6. So, madali lang siya. Ito times 2 lang natin siya. Kaya magiging 12 lang yung sagot. Di ba? So, next, sa B. B naman tayo. B. Okay, B. Okay, if the hypotenuse is equal to 10, what is the length and the shorter leg? So, unahin muna natin yung shorter leg. So, shorter leg natin is given kasi yung hypotenuse. So, unahin natin yung shorter leg. So, shorter leg is equal to 1/2 times hypotenuse. So, 1/2 times 10. Yung hypotenuse kasi natin is 10. So, magiging 5. So, then, sa leg naman natin is L is equal to square root of 3 times the shorter leg. Yung shorter leg natin is 5. So, square root of 3 times 5 is equal to 5 square root of 3. Yung sagot niya. So, sa C na tayo, guys. Sa C. Then, L, okay, or length or longer leg is equal to 7 square root of 3. Then, shorter leg, what is the shorter leg and the hypotenuse? So, hanapin naman natin yung shorter leg tsaka yung hypotenuse. Shorter leg is equal to square root of 3 over 3 times the leg. So, yung leg natin is 7 square root of 2. Shorter leg is equal to square root of 3 over 3 times the length. So, substitute lang natin yung L ng 7 square root of 3. Multiply natin siya sa square root of 3 over 3. Kasi, square root of 3 times square root of 3 is square root of 9. So, square root of 9 is 3. So, 3 times 7 over 3. Then, makakancel yung 3. So, matitira na lang yung 7. So, ang sagot natin is 7. Then, next, para makuha naman natin yung hypotenuse, which is given naman na yung shorter leg natin, which is 7. So, ito times 2 lang natin siya, magiging 14. So, ganun lang siya kadali, guys. Pero, pwede natin siyang i-recheck gamit yung Pythagorean Theorem. So, yun lang, guys, yung topic natin about for today, yung 45-45-90 right triangle theorem and 30-60-90 right triangle theorem. So, that's all lang po. Thank you.
Good day everyone, I'm Jenny Marie Baduria from BSEd Mathematics 2nd Year College. So, our topic for today is all about isosceles triangle, properties, and theorem. So, we have a goals, and our goals is to define isosceles triangles, state the isosceles triangle theorem and converse of an isosceles triangle theorem, and lastly is to prove the isosceles triangle theorem and the converse of an isosceles triangle theorem. So first, let us identify what is isosceles triangle. So isosceles triangle is a triangle with at least 2 congruent sides. So equiangular and equilateral may consider as an isosceles triangle based on the definition with at least 2 congruent sides. So let us consider the illustration above. The triangle ABC is isosceles triangle and it has 2 congruent parts, which are the side AB and side BC. So take note, guys, when we are talking about an isosceles triangle, it has a part. So let's identify the different parts first. So first is the congruent sides, or what we call the legs. So as you can see in our triangle, I indicated the 2 legs, which are the segment AB is congruent to segment BC. So the third side is the base. As you can see in our triangle, our base is the segment AC. And next, the angles opposite the congruent sides are the base angles. In our triangle, it already labeled. And our base angle for the triangle is angle A and angle C. And they are congruent. And last is the angle included by the legs is what we call the vertex angle. So, our vertex angle for the triangle illustration is angle B. Note in our isosceles triangle, we have two legs, one base side, two base angle, one vertex angle, and always the legs is congruent, same as the base angles. Let's go on in properties of an isosceles triangle. If we have given triangle ABC and it has congruent legs, which is segment AB and segment BC, and it has a congruent base angle, which is angle A and angle C, we can derive in the theorems under the isosceles triangle. So the first theorem is the isosceles triangle theorem, or the ITT. It said that if two sides of a triangle are congruent, then the angles opposite them are also congruent. So if our congruent side is segment AB and segment BC, then angle opposite is angle A and angle C. So if segment AB is congruent to segment BC, then angle A is congruent to angle C. In converse to that statement, our second theorem is converse of an isosceles theorem, or what we call CIT. It said that if two angles of a triangle are congruent, then the side opposite them are also congruent. So if the angle are congruent, definitely the side opposite them are also congruent. So if angle A is congruent to angle C, then segment AB is also congruent to segment BC. So to prove that theorem, we're going to use two-proof column to prove that the theorem is true. Using isosceles triangle theorem, or ITT, given segment AB is congruent to segment BC, we will prove that angle A is congruent to angle C. So we have triangle ABC is an isosceles triangle. So our next step is we'll bisect the angle B by an angle bisector. So as you can see in the triangle, it has a line from angle B to angle D, which is our angle bisector. We know that angle bisector is a line or ray that divides an angle into two congruent angles. So our statement is construct angle bisector of angle B, and the proof is every angle has one angle bisector. So if BD is an angle bisector, we can say that angle ABD is congruent to angle CBD. This is by definition of an angle bisector. And then for the other congruent side, we can state that segment BD is congruent to itself. This is by the reflexive property. And now we have enough information to state that two small triangles are congruent to one another. So we can say that triangle ABD is congruent to triangle CBD. Remember, these vertices must be listed in corresponding order, and the reason for this is the side-angle-side postulate. And since these two triangles are congruent, we can conclude that angle A is congruent to angle C. And the reason for this is that CPCTC, or the corresponding parts of the congruent triangle. And now we're going to prove the converse of an isosceles triangle theorem, or the CITT. Given angle A is congruent to angle C, we will prove that segment AB is congruent to segment BC. In this case, same thing will be done. We will construct again an angle bisector. We will draw angle bisector from angle B to angle D. And this is every angle has one angle bisector. From the definition of angle bisector, therefore, we can create two triangles which is ABD and CBD, and we're trying to prove they're congruent. Therefore, we can prove side AB and side BC are congruent using CPCTC. And next, angle ABD is congruent to angle CBD using the definition of angle bisector. And next, using the angle bisector that we draw, which is segment BD, is congruent to segment BD using reflexive property. So as we can see on the illustration, our triangle, we can see that we have angle side. Therefore, we can prove that triangle ABD is congruent to triangle CBD using angle side congruent postulate. Therefore, segment AB is congruent to segment BC using the CPCTC, and it will prove that they are congruent. If the two triangles are congruent, which is triangle ABD is congruent to triangle CBD. So, in applying in real-life situation, many things in the world have the shape of an isosceles triangle. Some popular example of an isosceles triangle in real life are the slice of pizza and a pair of earrings. Or try to make isosceles triangle and fold it, and it will tell us that they are congruent in terms of side or their base angles.
Similar triangles. Let's learn about the three-triangle similarity theorem. And let's apply the three theorems to determine if two triangles being compared are similar. So let us define the similar triangle. Two triangles are called similar if they both have the same three-angle measurement. Two triangles that are shown in this presentation are similar. Similar triangles have the same shape but possibly different sizes. You can think of similar triangles as one triangle being a magnification of the other. So in our first slide, we discussed what is similar triangle. And now let's see what kind of shape we will be discussed to define similar. So in geometry, two shapes are similar if they have the same shape but different sizes. So as we can see in our presentation, we could have squares with sides 21 cm, any square with sides 14 cm. And we can call them similar because they have the same shape but different in sizes. And if we compare an equilateral triangle with sides 21 cm that we can see on our left side, and the squares with sides 14 cm, it would not be similar because they are different in shapes. Correspondence. In geometry, correspondence means that a particular part on one polygon relates exactly to a similarly positioned part on another. So even if two triangles are oriented differently from each other, if you can rotate to orient in the same way and see that their angles are alike, you can say those angles corresponds. The three theorems for similarity in triangles depend upon corresponding parts. You look at one angle of one triangle and compare it to the same position angle of the other triangle. So included angles. The included angles refers to the angle between two pairs of corresponding sides. You cannot compare two sides of two triangles and then leave out an angle that is not between two sides. So here, as we can see, we have two congruent triangles. To make it easy, we have them both equilateral triangles. And as we can see, triangle FOX is compared to triangle HEN. Notice that angle O on triangle FOX corresponds to angle E on triangle HEN. Both angle O and angle E are included angles between sides FO and OX on triangle FOX and sides HE and EN on triangle HEN. The two equilateral triangles are the same except for their letters. They are the same sizes, so they are identical triangles. If they both were equilateral triangles, but side EN was twice as long as side HE, then they would be similar triangles. So similar triangle are easy to identify because you can apply these three theorems specific to triangles. These three theorems known as angle-angle or AA, side-angle-side or SAS, and side-side-side or SSS are foolproof methods for determining similarity in our triangles. So let's discuss the first theorem, which is angle-angle. So angle-angle says that two triangles are similar if they have two pairs of corresponding angles that are congruent. The two triangles could go on to be more than similar, they could be identical. And for angle-angle, all you have to do is compare two pairs of corresponding angles. So here we have two scaling triangles, which is triangle jump and triangle out. We have already marked two of each triangle's interior angles with the geometer's shorthand for congruence, or the little dash marks. A single slash for interior angle A and the same slash for interior angle U means they are congruent. Notice that angle M is congruent to angle T because they each have two little slash marks. Since angle A is congruent to angle U and angle M is congruent to angle T, we now have two pairs of congruent angles, so the angle-angle theorem says that the two triangles are similar. So next, let's discuss the second theorem, which is side-angle-side. So the second theorem requires an exact order, is side, then the included angle, then the next side. The side-angle side states, if two sides of one triangle are proportional to two corresponding sides of another triangle and their corresponding included angles are congruent, then the two triangles are similar. So here we have two triangles side by side and oriented in the same way. So triangle RAP and triangle EMO both have identified sides measuring 37 inches on triangle RAP and 111 inches on triangle EMO, and also side 17 on triangle RAP and 51 inches on triangle EMO. So notice that the angle between the identified measured side is the same on both triangles, which is 47 degrees. The two ratios are proportional since they each simplify to 1/3 with their included angle the same. These two triangles are similar. So let's move on to our third and last theorem. The last theorem is side-side-side or SSS. This theorem states that if two triangles have proportional sides, they are similar. This might be seem a big leap that ignores their angles, but think about it. The only way to construct a triangle with sides proportional to another triangle side is to copy their angles. So as we can see, we have two triangles, which is triangle FLO and triangle HIT. Notice we have not identified the interior angles. The side of triangle FLO measures 15, 20, 25 centimeters in length. The sides of HIT measures 30, 40, and 50 centimeters in length. And so as we can see, they are all the same ratio when simplified. They are all 1/2. So even without knowing the interior angles, we know that these two triangles are similar because their sides are proportional to each other.
Good day everyone, I am Unisal Dibar and I am going to discuss about the triangle inequality theorem. What is triangle inequality theorem? Triangle inequality theorem states that the sum of any two sides is greater than the third side. And of that theorem, we have here A plus B is greater than C, and A plus C is greater than B. And the third is B plus C is always greater than A. So, paano ba natin malalaman kung paano tayo makakabuo ng triangle? Sabihin na natin na ang unit ng A is 3, ang B ay 4, at ang C ay 5. 3 plus 4 is 7, di ba? So, is greater than 5. Tama ang ating first statement. Pero hindi lang yan dahil may dalawa pa tayong kailangan patunayan kung makakabuo tayo ng triangle. 3 plus 5 is 8 greater than 4. Tama pa rin ang ating number 2, kaya move on na tayo sa statement number 3 natin. 4 plus 5 is 9 and greater than 3. So, sabihin natin na itong 3, 4, and 5 can make a triangle. Para mas maintindihan pa natin, gagawa tayo ng mga example. So, magbigay naman tayo ng example kung itong tatlong number na to ay makakabuo ng triangle. 2 plus 4 is equal to 6, diba? Kaya greater than 5. Kaya tama na makakabuo yan. Pero hindi lang yan, diba? Dahil may dalawa pa. 2 plus 5 is 7 and greater than 4. So, tama din. Pwede rin tayo makabuo ng triangle. And last, 4 plus 5, which is 9 greater than 2. Kaya, pinapatunayan lang nito na pwede tayong bumuo ng triangle sa number na ito. Next example is, kung makakabuo tayo ng triangle sa 1, 2, and 4. Ayun na pa. Gagaya lang natin yung mga given na kanina. 1 plus 2 is 3. So, hindi siya greater than 4. Kaya, mali tong number 1. Pero, i-compute pa rin natin kung yung iba ay pwede. 1 plus 4 is greater than 2. So, tama yung number 2. 2 plus 4 is 6 greater than 1. Kahit na tama itong dalawang to, basta may mali sa isang statement ay no, hindi na makakabuo ng triangle. Hindi ka makakabuo ng triangle sa number na ito.